Question number 1 is reviewing how to graph a piecewise function. Now, for every function, there's an input, and it gives you an output. The inputs that we're going to use are the values of x. X is typically, in this case, also represent inputs. So we have inputs that are less than or equal to a -2, and our output will be a -x if we use those input values. So we have these defined regions where we are putting in different values for input, and if that's the case, we have different outputs that are going to be assigned to them. So what I did is I highlighted each of those input regions. The first region I inputted, get this to work, is I'm going to do it in blue because that's how I got the blue shade there. So in order to graph a piecewise function, what I want to do is I want to find the edge of the interval, and then I want to use the idea of graphing the rest of that function. All of these in this part here are linear functions. So since they're linear, they're all in a certain form of mx plus b, our slope-intercept form. So if it's in our slope-intercept form, I can use that to help me graph at least portions of that. So what I want to do is the first thing I'm going to put in is a -2. I'm going to put it in for this function into the -x. So I'm going to evaluate our function f of x for this first piece, which is a -x, when x is a -2. So I'm going to put in that -2, and I'm going to say, what is f of a -2? That's a negative of a -2. The output is a 2. So on that very edge of that interval, what I want to be able to do is I want to be able to graph the ordered pair. I put in a -2, and I got back out a +2. So that's my input and my output. I put in the -2, I got back a +2. And because it's less than or equal to, what I want to do now is I want to shade in that dot. So that's the first point that's going to be graphed in that interval. Now the next thing after that, I want to use the slope of our line. Since I have, in essence, y equals -x, my slope is a -1. The slope of a -1 would be, go from the starting point that I have. I could go down one, right one, but that puts me in the wrong interval. So instead of going down one, right one, down is negative, right is positive. What I want to do is go up one, which is positive, and then left one, which is negative. Gives me a second point. And that's the point I'm going to use to help define the rest of that interval. It's going to go on that way forever because the x values are always less than or equal to a -2, so it goes on to infinity. So there's the first piece of my graph. So then I'm going to work on the second piece. The second piece of this graph is defined to be f of x equals 2x plus 1. Now this one, I've got two ends of my interval, so what I want to do is I want to plug in each of these to see where my function is defined on the very ends of this. So on this end of the graph and on this end of my graph, or the interval, I'll know where my points are. And I only need 2 points to graph the line. If I got 2 points, then I can draw a line between them, and the path is fixed. So I'm first going to put in f at -2. F at a -2 in this function says I've got 2 times a -2 plus 1. That's a -4 plus 1, which is equal to a -3. So when I put in a -2, I got -3 back. So I'm going to graph the -2, -3, -2, -1, 2, 3. This time it's going to be an open circle because it's just less than a -2. Then I'm going to come back and I'm going to run another calculation. I'm going to use the right end of the interval. So now I'm going to calculate f at 1. And this is going to be 2 times 1 plus 1, which gives me a 3 plus 1. Or I get a 2 plus 1. And then we add the 1 to the 2, and we get 3. So when I put in an ordered pair of, or an input of 1, I get an output of 3. So my ordered pair is 1, 3. This time I'm going to make sure it's a closed circle because we get to include 1 in that interval. So I go to 1 and then go up 3, 1, 2, 3, close it. And if I connect these 2 points with a solid line best as I can, I don't think I did it very straight. Let me try it again. That will be the path of our line. I could get out my own line drawing tool. There we go. Okay, so that's my second piece. Now the third piece comes in by using the third part of that. So I'm going to clear some workspace off. The third piece says that f of x is a -2 as long as x is greater than, as long as my inputs are greater than or equal to 1. So f at x is defined to be a -2. Our output is defined to be -2, whatever we put in for x. So if I put in a 1, it's just a -2. So in the ordered pair, since there's no x to put it in for, the ordered pair, if my input is 1, the output is a -2. So I can graph that ordered pair, 1, -2, 1, -2. I want to make sure it's an open circle on that because it's just greater than 1. And then for every x value greater than 1, it's always a -2. Or as we talked about in class, when it's just equal to a constant, it's going to be a horizontal line. So there's the piecewise function that we should have had for question number 1. Graphing in different intervals, using your ideas of slope and intercept and your horizontal lines to help you graph.